So we are starting chapter 10. It's kind of a long chapter, about 8 sections, and it deals with circles, which is nice because it kind of leads us up to Pi Day on Friday. A circle is the locus, which is kind of the location, okay, of all points in a plane equidistant from a given point called the center of the circle, named by the center. Okay, so when it says the location, it means the location of all the points. If I were to take a compass or even a string with a pencil attached at the end, and I were to locate it at the center and I were to mark it all the way around, I stay equidistant all the way around, don't I? Okay? If I open that compass to be a certain width, or my string stays consistent all the way around, the distance from the center to the circle should stay the same. Otherwise, it's not a circle, right? It's some wiggly oval or, something weird, okay? All right. When you name a circle, you name it by its center. And so this would be called center or circle C. And so in your book, you'll probably see something like that, a circle with a dot, and then they use whatever the center of the circle is, okay? A radius is any segment with endpoints that are the center and a point on the circle. So a radius has one endpoint at the center, one endpoint on the circle, and it's that segment, okay, that connects the two. The plural for radius is radii. Okay, that's the plural. So CE is one of my radii. Give me another one. CF is another one. And CD. Okay? All right, so CE, CF, and CD, those are all radii. Now, another segment in a circle is called a chord. Okay? And a chord is any segment with endpoints that are on the circle. So A is on the circle, B is on the circle, and the segment that connects them is called a chord. Okay, so AB is a chord. What's another chord that you see there? FD is another chord because it has its endpoints on the circle. Now FD is a special kind of chord because it actually goes through the center. Okay, and so when you have a chord that goes through the center, that is actually called a diameter. So FD is also a diameter, and it's made up of two what? Two radii, okay? So your diameter is 2 times the radius, or if you work backwards, your radius is what times the diameter? 1/2. All right, so let's work a couple of problems. Circle A has diameters of DF and PG. Okay, what's true about all the diameters? Like, let's say that DF was 15. What would PG be? 15. They're always the same, right? Okay. So, but this time, let's say that DF is 10. What would DA be? 5. It's going to be half of it. Okay. Here's a new problem. If PA is 7, what's PG? 14. Okay. And how about if AG is 12? What is LA going to be? 12. Okay, so all your radii are the same. That's what makes it a circle, because they're equidistant from the center. Okay, here's some special types of circles. We have congruent circles, and congruent circles are two circles that have the same radii, basically. So if GH and JK are the same, then we would say that those circles were congruent. Similar circles are circles that well, all of them are similar, okay? Triangles, you had special rules, right? The sides had to be proportional, the angles had to be congruent. But circles really just have one linear measurement, the radius or the diameter, whichever one you look at. But basically, all circles are similar. Then you have concentric circles, okay? Concentric circles is like a bullseye or a target sign. And it's basically a circle within a circle. They have the same center. So we have this circle A right here that has a radius AB, right? But then we also have this circle A, has the same center, but it's got a different radius, AC. So they're coplanar, so they're all in the same plane, and they're kind of nested inside each other. They have the same center, but different radii. So it's concentric circles. Now, circles can intersect in different ways. Okay, they can have 2 points of intersection, kind of like a Venn diagram. Okay. They can have 1 point of intersection where they intersect you know, the two circles are outside of each other and they intersect at one point. One could be in the other, but not necessarily concentric. And so they touch there at that point. And then they can have no intersection, just two random circles, or again, circle within a circle, but not touching. Okay, concentric circles would be an example of that. All right, so a couple of examples here. It says the diameters of circle A, circle B, and circle C are 10 inches, 20 inches, and 14 inches respectively. That means that A has a diameter of 10, B has a diameter of 20, and C has a diameter of 14. All right, so we want to find XB. Okay, so we know that circle A has a diameter of, circle A has a diameter of 10, which means QA is what? 5, and it means that AX is what? 5, okay? Then it says circle B has a diameter of 20, which means it has a radius of 10. So this length right here is 10. So if this is 10 and AX is 5, what's BX going to be? 5. Okay. All right. Now we want to find BY. Okay. Now remember that my radius for circle B is still 10, right? The diameter of circle C is 14, which means the radius is what? 7. So if this whole thing is 10 and this is 7, then what's BY going to be? 3. Okay, and then we want QR. This is going to be 7 right there. And we said this was 5. So we could add each individual piece together here. We wouldn't want to add all the diameters together because they overlap, right? Okay, so we couldn't do that. So we could add the individual pieces together. That'd be 5, 10, 15, 25 plus 7, what's that, 32? Okay, we could do it like that. Another thing we could do is we know that A has a diameter of 10 and C has a diameter of 14, and this is all we would need because the rest of it overlaps, right? And so then that would be 8, and we could do it like that too, okay, and add those pieces together. All right. Now, circumference. Circumference is the distance around a circle. Like if I were to take a string, okay, and wrap around this circle and then cut it and lay it out flat, that is the distance around the circle. That's called a circumference, okay? Have you ever seen one of these? Have you ever seen a policeman use one of these, or maybe a construction worker? Huh? Maybe or a surveyor or something? And what they do is they take and they go and they measure, right? And every time it clicks, it means it's gone around once, okay? And so they use this. Well, what it's doing is it's using the circumference of the circle to measure a flat distance. So if you've ever been like at a wreck, you'll sometimes see them and they'll measure like the skid marks on the road, and then they can use that then to determine how fast the person was traveling or how close they were traveling. Okay, so they use that information. Surveyors do it to measure, you know, like when they built my house. They had one of these and they had to go and mark the different links and put markers so that they know where to put the house. Okay, it's easier to use something like this and use the circumference of the circle than it is to get a big long measuring tape, right? I mean, one person can do this, whereas you would have to have 2 people probably for the measuring tape, especially for a long distance, right? And so anyway, they use these to measure circumference. Okay, so the formula for circumference is pi times diameter, or 2 times pi times the radius. The diameter is 2 times the radius, so hence they're basically the same formula, just written in a different way. Okay, so what is pi? Well, pi is a ratio of the circumference of the circle to its diameter. So if I got a measuring tape and went all the way around the circle, took that distance, then I measured across the center through, you know, the diameter through the center, I divided those, I'm going to get the same number every time, no matter how big the circle is, okay? And it's going to be approximately 3.14. I've got pi written across the back of the room out so many digits, but it is what's called an irrational number, okay? And no matter if you take any circumference of a circle and you divide it by its diameter, you're always going to get that approximation, okay? And so people have taken pi out millions and millions of digits, okay, looking for some kind of repeating pattern. But because it's irrational, it goes on irrationally. There is no repeating pattern. It doesn't ever stop. It just goes on and on and on and on and on and on and on. Okay? And so that's what pi is. And since it's approximated 3.14, that's why we celebrate Pi Day typically on March 14th, 3.14. But we're not going to be here, so we're going to do it on 3/13. Okay? So we're close. Okay? But anyway, so pi is your irrational number. Now, on your calculator, there is a pi button, okay? And so you'll be using that pi button. Sometimes it says use 3.14 for pi. That's what you need to use if it says to use 3.14, okay? But if it just says round to the nearest hundredth or round to the nearest tenth and it doesn't specify, then you need to use your pi button. Sometimes they ask you to use 22 sevenths, okay? That's another approximation for pi. So, we will more than likely use the pi button unless it specifies for you to use 3.14. So you always need to read the directions and use what they tell you to use. Okay. All right. Now, let's find the circumference, okay? Now, I kind of like the pi times diameter a little better just because I can usually do this in my head and find the diameter and then just multiply by pi. So, if I wanted to find the circumference, my radius is 7. What's the diameter? 14. So my circumference would be 14 pi. Now, this is what we call an exact answer when you give it in terms of pi. And that's important because if we're going to use this answer to calculate something else, we want to keep it exact until the very end. Because with any problem, the more you round, the further away from the answer that you get. And so you need to work with it in terms of pi. And the pi, until the end, acts as a variable. So it would do everything a variable would do, okay? So anyway, this would be an exact answer. Remember, an exact answer is not rounded, okay? Some of us still need to get that straight on the radicals, okay? Because, you know, radical 2 is an irrational number also. So is radical 3. And so if something says exact, it means it's going to be in terms of pi. It's going to have a radical in it. It's going to be a fraction that you know, you can't divide out and get a terminating decimal, okay? So anyway, so this would be considered an exact answer. But if I plugged it into my calculator and I put 14 pi in there, oops, I gotta turn it on. 14, and then you hit that pi button, and then you hit enter, you get, if it was the nearest hundred, it would be 43.98. And I'm going to use a squiggle here, a double squiggle, because that's an approximation, okay? This is an exact answer. This is an approximated answer, okay? All right, what would the exact answer for the second one be? Find the circumference if the diameter is 12.5 inches. 12.5 pi inches would be my exact answer. But then, if I plug it in, I get 39.27. And that would be an approximation. Okay, sometimes they ask you to work backwards. Okay, they give you the circumference and they ask you for the diameter and the radius. Okay, it may ask you for exact, it may ask for rounded to the nearest hundredth. Okay, so we utilize our formula, pi times the diameter. It gives us circumference, so we replace the circumference with 136.9 equals pi times the diameter. So to find the diameter, what would I do? Okay, you would divide by pi. Okay, so if I take 136.9 divided by pi, you end up with 43.58, the diameter. Meters. Then I would take that answer, and honestly, I would leave what was in my calculator and divide by 2, and it's 21.79 meters for my radius. Now, let's say they didn't ask for the diameter, they only wanted the radius, okay? You may or may not do this, but knowing this is important, okay? All right, so let's say I wanted the radius. And so instead of setting my circumference equal to pi times diameter, I did 2 pi r, which is the same thing, yes? Okay, so again, I would replace my circumference with 136.9 equals 2 pi r. And so to get r by itself, what would I do? Divide by 2 pi, right? Now, if I plug this into my calculator, remember I told you that your calculator knows its order of operations better than you ever will, right? So if I plug this into my calculator is going to do 136.9 divided by 2, then it's going to take that answer times pi. Is that what we want? No. We want to divide this whole thing by 2 pi. So what are you going to have to do? You have to put it in parentheses. Okay? So if you ever divide by something that is a quantity like 2 pi, then you need to put it in parentheses. Otherwise, it does its own thing. Okay? Okay. Find the exact circumference. Okay, now, in order to find circumference, what do we need? Diameter, right? So I look at this, and here is my diameter. Okay? My pen is off, but anyway, that's my diameter, okay? Now, what is this line also?
Hypotenuse.
It's the hypotenuse of a right triangle, isn't it? Okay, here's a right triangle. It's the I'm gonna redraw. It's just like a little bit off, and I centered it earlier today. That's a little bit better. Okay, so it is the hypotenuse of this right triangle. Well, what is that hypotenuse?
13.
It's 13, okay? How many of you didn't know that? Okay, remember I told you about triples? And I told you there were 2 of them you needed to memorize, right? For sure. I mean, you know the other ones, but 5, 12, 13 was one of them, okay? The other one was what? 3, 4, 5. And you're going to use these all the time for the rest of the year, okay? Because we're going to be working with these little right triangles for volume and surface area and all kinds of stuff, okay? So it'd be beneficial for you to memorize those. But you didn't know it, right? So what would you do? You would have to go ahead and do 5 squared plus 12 squared equals c squared. Could I use sine, cosine, or tangent on this? No, we don't know any of the angles, so we don't care what the angles are, right? We just want the length of that third side. That always requires the Pythagorean theorem. Okay, so we know that my hypotenuse is 13. We also know that 13 is the diameter of my circle. So what would be the exact circumference? 13 pi, because it's pi times the diameter, so it would be 13 pi. And pi, kind of like I said, acts as a variable, so it goes on the right side instead of the left side of the number, okay? All right, last thing. I think we've talked about this a little bit back in one of our other chapters. An inscribed polygon is a polygon in which each of its vertices lie on the circle. So this right here, I'm going to highlight it in blue, is an inscribed polygon, which means each of its vertices lies on the circle, okay? Now, I could look at this picture differently, and I could say that this was a circumscribed circle. And that is a circle that contains all the vertices of a polygon, okay? So if I looked at this, I could say that it's an inscribed polygon, and I'm talking about the polygon. It's in a circle with its vertices lying on the circle. I could also look at this and say this is a circumscribed circle because it surrounds the polygon and contains each of the vertices of the polygon, okay? So that's going to be important to remember for things coming up. All right, any questions? Okay.